Hello and welcome to the Daily Space for today, February 21st, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Today is going to be one heck of a busy day here on CosmoQuest X. In addition to the daily space, which I am about to do, which is why you're all here, we are also going to be coming to you live later today to bring you coverage of Hayabusa 2 going in for a snatch and grab off of the asteroid Ryuga. And we are also going to be here to bring you live coverage of the SpaceX launch that includes Space IL's little moon lander on board. So, today's the day where you kind of want to be prepared to linger on Twitch because all the space science is coming to you. For now, though, I have stories of discovery rather than stories of launches and landings. And in today's first story of discovery, I have a story that is getting slightly mangled in the press of Neptune's little moon, Hippocamp. Now, this is one of the sillier names that I think a moon has ever been given. I, for one, imagine all of the hippopotamuses from Disney's Fantasia attending camp on this moon, because Hippocamp, but that may be my overactive imagination. This little world was found back in 2013 in Hubble archive images of Neptune. And it is only this week that it is really getting the attention it deserves. And this attention comes for a combination of reasons. One, it now has a name. And two, it's looking like it may have been formed through a collision of various objects in orbit around Neptune. Its orbit is quite strange, but so is its discovery, and I actually want to discuss this for a minute. Thank you, Hajacorn, for hosting our stream. So when you look at Neptune with the Hubble Space Telescope, there are a series of rings around this world. And trying to image these rings is extraordinarily difficult because they move rather rapidly and they're extraordinarily diffuse. So trying to image them from the surface of the planet, where you'd need to take long period exposures, you're just not going to end up seeing them because their light gets smeared out as they move around on the sky. Back in 2013, astronomers from the SETI Institute, trying to study those rings, figured out that what they could do, instead of taking a long period exposure, was to take a series of shorter exposures and align those images using the rings as the point of alignment so that they could bring out the light from the rings. In the process of doing it, the scientists looking at this, what they discovered was nestled in those rings are a whole series of moons, most of which were known about, but one that wasn't. This is work that was done by Mark Showalter, and what he found in lining up the rings was that in image after image, there was this faint little speck that moved and acted just like a moon, and in fact was a moon. This little tiny object had gone completely unnoticed by the Voyager 2 mission because it's only 21 miles or 34 kilometers across, and at that size and at that lack of brightness, it just wasn't something that Voyager was able to see. And one of the things that's truly amazing to me is we can see it from here on Earth because Hubble's that much bigger than little Voyager's cameras were. It's kind of the difference between trying to zoom in on something with your smartphone versus trying to zoom in on it using, well, a backyard telescope. In this case, it's the difference between Voyager's onboard camera, which was more like a backyard telescope, and Hubble, which is kind of the size of a school bus. So thanks to one guy trying to look at those rings and finding a new technique to look at the rings, a new little world was found. And in the years since 2013, a series of follow-up observations have been made. And it's in those follow-up observations that they were able to figure out, and from reanalysis of 150 archival images taken between 2004 and 2009, that they were able to figure out that this little moon is literally a chip off the old block, where the old block is probably a different moon. Now, that's not a lot of details, and this is just one more reason we really need to have a dedicated mission that goes out to these outer worlds. We haven't done this because it's hard, it's expensive, and let's face it, Neptune and Saturn, everyone gets excited about those. They look cool through your backyard telescope. They have dozens of moons that we know about. They have storm patterns at Jupiter, ring patterns at Saturn. It's harder to get people excited about, well, Neptune and Uranus. They just don't have the same drama going on. But maybe they do, and we just haven't seen it because we haven't sent the mission out. So here's to hoping this one new interesting piece of science is that one more justification to send a mission out to study these icy giants. In other news, it turns out Earth's atmosphere, for very small values of atmosphere, actually stretches out beyond the moon. This is another news story that relies on archival images to get at the full story. Back in December 1995, the SOHO Space Observatory launched to observe the sun, but in 96 and 98, it decided to turn away from our nearby star and instead look back at us. And from its position midway between the sun and the Earth in a gravitational sweet point called a Lagrange point, it's able to balance between the Earth and the sun and maintain, well, a constant view of whichever one it wants to turn around and look at. When it looked at the Earth, it did it with an instrument that explores the sky in the ultraviolet, allowing hydrogen to show up through its Lyman alpha transition. This is the 2-to-1 transition of electrons in hydrogen. When the electron makes that jump from the second orbital level to the first orbital level, it gives off a specific color of light. That photon is an ultraviolet photon. We call it Lyman alpha because it was a scientist whose last name who was Lyman that first figured this stuff out. And it's the first in the series. So there's a Lyman alpha, a Lyman beta, and each of these different transitions have their own specific color. Well, Lyman alpha is a super common transition, and looking back at the Earth from its position shown here in this image, it's possible for SOHO to take an image through whatever hydrogen surrounds the planet Earth. And when it did this, what it saw was this crazy diagram. Fake color. This is false color. This color is denoting the density, where red is high density, blue is low density of the hydrogen gas surrounding the Earth. And this dotted line, that dotted line is the moon's orbit. And it turns out that the solar wind, going back to that earlier illustration, that solar wind, as the sun's down here, solar wind is pushing this direction. The solar wind pushes the hydrogen that surrounds the Earth's geocorona is what we call this, pushes it outwards, creating a stream of gas around the Earth. And that stream of hydrogen gas, the geocorona, expands out so far that it actually surrounds the moon. Now, this gas isn't useful for much other than to put drag on our spaceship, so it's actually a bit problematic but cool. So we have one more thing to account for when we figure out how much drag is on our spacecraft, even at the distance of the moon. But we also have one more scientific discovery. Now, all of that hydrogen is eventually going to just get blown away and replenished from more hydrogen getting released from down in our world. Hydrogen, there's a lot of it, so it's going to be a long time before we run out. But the same thing is happening to helium gas. And this is my regular reminder that helium is a non-renewable resource. When you get a helium balloon and it goes from happily floating to lying on your floor because the helium escaped, well, that helium that escaped is going to get knocked around by oxygen molecules in the atmosphere, accelerated to escape velocities, and it's going to say goodbye to the planet Earth. And we need helium gas for scientific experiments, for medical imaging. So if you like your lungs and want doctors to be able to image them in your old age, young age, or whenever doctors may need to image them, don't buy don't buy helium balloons, and don't let the people you like, love, or anyone, even the people you hate, buy helium balloons. So that is my soapbox for the day. Returning to science, we have news coming from the University of Texas and Penn State University, which are two of the leading partners on the Habitable telescope located at McDonald Observatory out in West Texas. This massive telescope with a 10-meter segmented mirror has turned on and begun exploring the skies with a rather non-photogenic new spectrograph. This particular series of, well, mostly aluminum boxes that have within them fiber optics, diffraction gratings, and a whole series of other optical entities. This instrument is going to be exploring the regions of cool stars, looking for planets that just might be capable of having life. Now, this is just one more instrument of many scattered all about the world. But this particular instrument, well, it has one job, and it's kind of cool. And the reason I'm bringing this up, and I don't usually do that many instrument stories until they have science discoveries coming out, this is actually built on a telescope I used in part for my dissertation. So it has a sweet spot for me, even if I never would have used it to hunt for planets. And this is also an instrument that's been a long time in coming. As early as the 1990s, when astronomers first started discovering planets orbiting other stars, they've been trying to figure out how to use the Habitable to be part of that discovery process in ways other than just identifying the Doppler shifting of stars as planets tug them to and fro in the sky. And it's exciting to see how, after so many decades, there's now a great new instrument that's going to help us find habitable worlds orbiting alien stars. So that is today's news here at the Daily Space. I am now here to answer your questions, and I'd ask you to please, as you type them in, remember to @CosmoQuestX so I can find them quickly in the chat. While you're typing those in, I'm going to give you our standard reminder that the Daily Space is part of CosmoQuest. We're your place to learn and do science. And the Daily Space isn't our only show. Later today, as I mentioned earlier, we will be back. I will be back probably sometime around 5 p.m. Eastern Time. Check Twitter to catch all of the details coming. To bring you live coverage of Hayabusa 2 as it goes in to snatch a rock off the surface of the Ryugu asteroid. Following that, a few hours later, our own Annie Wilson will be here bringing you live coverage of the SpaceX launch, which carries with it a little lander brought to you by Space IL. This will be a new nation setting, well, robotic foot on the moon. Israel joins the family of the United States, Russia, and China in being a moon explorer. And all of that will come to you live right here. So give us a follow, get notifications when we go live. And we are here because of you. This is a production of the Planetary Science Institute working in collaboration with Youngstown State University, and we are sustained through your subscriptions. Every bit really matters. And we are able to do this because of your financial support. So thank you so much. We are so very grateful for all you do to let us bring science to the world. So I'm now going to take a look at what questions you had for today. Okay, let's see. Yeah, I'm not a Pam, but that's okay. Pamela, just moving forward. So Veronica Cure says, could CubeSats be sent to far out planets in our solar system? Not yet. The technology's just not quite fully baked. And there's also a second problem with going to the outer solar systems to do more than just a flyby. And that's that you have to do a fairly significant change in velocity. With CubeSats, like we sent to Mars along with the InSight lander, they don't have significant rockets on board. They don't have significant fuel on board. And so while they're capable of minor course corrections, they're not capable of the braking, the change in direction that's needed to go from flying toward a world to actually orbiting a world. To get to Neptune or Uranus in anything less than decades, you're going to have to get a pretty hefty velocity going. You're also then going to need to shed all of that velocity to go from flying toward Uranus to going around it and not flying away from it. CubeSats just don't have that capacity yet. And for reasons that we don't fully understand, we also lost track of MarsCo A and B, those two CubeSats. And until we're able to consistently build CubeSats that work in the inner solar system, we're probably not going to spend the money to send CubeSats to the outer solar system unless they're accompanying another spacecraft that's already funded. Testing new technologies is always so frustrating. So Hanny's Vorverp is asking, are those pictures of planets in that last story's picture? I think that you're asking about this. So if this is the image that you're talking about, this is a combination of a Hubble picture of Neptune that was taken through multiple filters and then layered together to create a shiny, pretty picture of Neptune. And this is surrounded by different images that were stacked in a different way in black and white to show us all of the different moons of Neptune. I hope that was the question you were asking. So Binary Ablaze is asking, is this HET-DEX? HET-DEX is the Habitable Telescope's Dark Energy Explorer. And no, that's a different instrument that is also in the basement of the Habitable Telescope Observatory. It's a big basement filled with many fiber-fed instruments. They're just different instruments with different capabilities. So Larry is asking, where did Soho launch? I think it launched from Canaveral, but I'm not entirely sure. It was a long time ago when I was still an undergrad, not paying attention to these things. Actually, was I still an undergrad? Yes, I was still an undergrad. So Henny's Ververb asks, can electrons only jump if they're in the outer ring of electrons around the atom? No, they can actually, so you can end up with multiple excitations going on, but there's a much lower probability. It gets complicated. So the answer is no, other electrons can jump around, but it's less common and more complicated. So Henny is asking, do we think Neptune's rings are old because of their darkness and thinness? I don't know. There's lots of different papers out there, and coming at this from an astronomy background, I'm not sure what the dominant theory is. Yeah, Henny, the answer to most of your questions is I don't know. Sorry about that. Okay, scrolling down to see what other questions we have. I also don't know when it launched. It was December 1995, I believe. Yes, December 1995, but I don't know the exact date. Typing is hard, Larry. Typing is hard. Okay. Oh, 2 posters in the background of the Hobby Everly. No. Oh, there appear to be 2 things in the background. I have no clue what those are. Sorry. I agree. Let me see if I can zoom in on this. There are 2 brightly colorful things back there. I suspect that those are actually gas cells used for calibration, where each of these is filled with a different gas. And the reason that they look so funky is they are reflecting light off of this aluminum foil that is here to protect the 2 systems from dust. That is me intuiting based on what I know from seeing other instruments. Sorry that that's not an entirely definitive answer. Okay, do we have any other questions? Otherwise, Annie and I have a whole lot of prep to do to make sure that we have awesome coverage to you that is well advertised on the Twitters. If you haven't already, join our Discord, and that's another place where we announce everything that's going on, and it's also a good place to go and join in random conversations. We discuss everything from the science going on around CosmoQuest to launches, landings, robots, memes, and we have a Games and Gamers channel where sometimes you can just find someone else to talk science while playing a game of Uno. So check it all out over on Discord, and thank you for being here. And seriously, today is the day that if you haven't followed us before, follow us now, because these snagging grabs of rocks and launches of new landers, it's going to be a good day. So thank you all for being here, Fenring. Oh man, UTC. I'll post all of that on Discord. I don't have that in front of me because I am a bad human being. Late. The answer is late. Sorry. Okay. So, I'm going to find someone to raid, roll the credits, and give that person, whoever they may be, and I'll tell you who they're going to be in just a moment, a hearty rocket welcome. The place that I go to find someone to raid is the Knowledge Fellowship. This is a collection of streamers who are here just to stream science. So it looks like C# Fritz may be streaming. Let me make sure he's still going. No, but there's someone called ZachOx1000 who's streaming science and technology and appears to potentially be doing game design. So we are going to raid a completely random human being who I know very little about. Be friendly, be nice, and let's prepare for more science to come. So, as I said, I'm going to roll the credits, and I'm going to see all of you later today. Until then, have a fabulous morning, evening, afternoon, wherever you may be in the world. And remember, if the weather's willing, get outside and look up. Bye-bye.